We weren't just moving to the cloud. We were splitting up the monolith, we were splitting up our mono repo, and we're converting to .NET Core. So we're doing a lot all in the one go. But our main reasons why we wanted to do this was to improve developer experience, to improve build times, to improve test run times. And for me, as a dev, the thing I really care about is time it takes to get your code merged and into production. So we were doing daily releases, and they were all, I wouldn't say manual, it's a whole automated process, but it's a custom process that we wrote. So we wanted to get rid of that as well. Observability, we wanted to know what was slow, we wanted better logs, we wanted better metrics, we wanted better error viewing errors and stuff. We wanted to embrace cloud services. So we wanted to be able to do dynamic scaling. As I said before, we were massively over provisioned for peak load time. We wanted to be able to scale down when we didn't need it. We wanted multi-region for performance reasons, and we wanted to be able to spin up a new cloud service. If we needed a new database before, we'd have to provision a new server, a couple of servers, install the software, keep it up to date, patching, blah, blah, blah. In cloud, you can say, give me a database, and you get a database. Awesome. And Rome2Rio, two big concerns, security and performance. So we wanted code to be more secure, we wanted the app to be more secure. We wanted read-only containers, we wanted infrastructure as code so we could spin up the whole site if we wanted to. And performance, we didn't want to slow down our site. Performance is a big, big deal for Rome2Rio. We have lots and lots of pages. We want them to be indexed by Google very quickly. So in this talk, I'm going to talk about our strategy, talk about decoupling, HTTP, then the actual migration and what the outcomes were. So let's get started with the strategy. So here's a plan of attack. This is our monolith, which I've just invented 4 different services, logical components, I should say, not services, logical components, as an example. So we had a lot more than this, we have a lot more, and some of these, I just made these up. We have, as an example, we might have 4 different components, logical components for our app. Pricing, trip building, SEO, and translations. We do a lot of SEO, and trip building is the actual algorithm that calculates how to get from here to here to here. So our strategy, big picture-wise, is to move that code out to a separate service, slap an API layer over the top, pull out all that trip building code, logic, move it to a different service, put an API layer over the top, change the monolith to call that API, and then get rid of that code. Does that make sense? Did I go through that too quickly? Because that'll then reduce the size of our monolith. It'll get a part of the code running in the cloud. I'll explain how we do all that in a sec. And then keep moving stuff, more and more stuff into the cloud as smaller services, and then hopefully end up with a much smaller monolith that we then bung into the cloud as well. So to take an example, so how are we actually going to do this from C# point of view? We started with our Rome2Rio web application, which is .NET Framework. And the first step was to grab the trip building logic, find the trip building logic in all of that code, and move it out to a .NET Standard project. .NET Standard 2.0, we're running .NET Framework 4.7. So move that all out to a .NET Standard project and have as much, all the trip building code in the trip building project. Then build a .NET 9 small API application that references the same code. And then that becomes our new service. You'll notice that the line connecting Rome2Rio web to trip builder still exists. So, and then actually call the API from the monolith. You'll notice that that arrow still exists. This means we can do both at the same time. So we call the API to build our trip, we get back the result. We also do the trip building inside Rome2Rio web, and we compare the 2 results and make sure that they're giving the same results. If they're not, we know there's something wrong with Rome2Rio web or something wrong with the trip builder API, because the .NET Standard code, it's literally the same code. So it was a really nice approach because it means we could just gradually move our code into the Rome2Rio trip builder .NET Standard project. We could do this daily, we could keep deploying the monolith to production, and the monolith in production will be using the new trip building code. It's the same code. So we really wanted to avoid the huge big bang approach, and this lets us get there. For our very first service, we did do the big bang approach because the amount of code was only like sort of 50 files compared to the trip building, which is heaps bigger. And of course, as soon as people then want to start making changes to that code while you're migrating it, It's a nightmare. Don't do that. So we did it all in the monolith. We did it all in the mono-repo. So that's all well and good from, and then once we're all happy that it's all good, sever the link from Rome2Rio web to trip building and call the API for everything. So how are we actually going to do this from a coding point of view? At the class level, here's our code, application code, calls the trip building code. I just invented 3 classes that calls route builder, that calls route finder. We want to move the bottom 3 classes into a new .NET Standard project. What you need to do is start at the bottom of the dependency tree. So route finder isn't referencing anything else. So it's easy to grab that class, move it into your .NET Standard project, and then add a reference from your .NET Web, .NET Framework project and reference the route finder class. As part of doing that, you need to upgrade the code to .NET Standard, which wasn't too hard for us. But third-party dependencies, you need to make sure any NuGet packages that are Windows only, we want it to run on Linux as well. But any projects that are referenced that are not .NET Standard, that needs to be fixed. So then we slowly move everything else into that project, trying to work out where the dependencies are and slowly moving them all into your .NET Standard project. This is all done in the mono repo. And then, like I said before, we're going to then add our trip builder API .NET 9 application and reference that common project. And I think I said this before as well, make the HTTP call down to there and get rid of that link. So that's all well and good from just moving files around, but files might have some code that's got something to do with trip building and some might not. So if we keep it all within a mono repo, the problem that you will inevitably have is that if there's code that's referencing that trip building code, even if it's calling the API, there'll be some coupling that's creeping back in, that's calling code that's inside your trip builder project or even within the API project. So we want to get to this state where we've got our separate mono repo, we've got our trip building repo that's completely separate, but the problem is this link here. And I'm really good at PowerPoint animations and all that. So I was trying to illustrate the point how that arrow is actually massive and lots of connections. They're all the ones you're going to have to gradually get rid of. That was terrible on purpose, by the way, in case you're wondering. Right, so this is where things start kind of getting difficult. So in reality, we may think we have something like this, our application code that's referencing our 3 classes, and we're in a mono repo. So what always ends up happening is there's more and more apps that get added to your mono repo and they start referencing more and more classes and code inside your mono repo. And you've got lots and lots of apps, lots of things pointing towards different classes, but we want to move all this out to a completely separate repo. So all the code that's reusing that stuff, they need to go via the API. All they need is a couple of different approaches we can use to fix this problem. So I think I've worked out about 5 or 6 different approaches that we found most useful, techniques you can use to sever these dependencies. First one, if it's an app that hopefully people don't care about or forgotten about or no longer using, delete it. The amount of times we posted and said, hey, is anyone using this class? Anyone using this program? Anyone using this functionality? And people go, I think we really need it. Delete it. It just saves so much effort when it comes to porting. And it's, it's always in source control. You can always recover it. You never need to recover it, but yeah. So delete is the big one. Duplicate it. If you need some of the route finding logic in Rome2Rio web, you could duplicate it. It's an option. Hopefully it'll send a shiver up the spine of every developer who doesn't want to duplicate code and knows how horrible it is. But if we're going to move off these 2 things, the 2 completely separate teams, if it's simple code, if it's just doing nothing, not business logic code, if it doesn't matter, there might be 2 different copies of it running in 2 different places, not the worst thing in the world. You can duplicate it. I know it might sound horrible, but you can do it. It's an option. What's our next option? We can turn it into a NuGet package. So if we do actually want to version that logic, if there's some logic that's in the route finding logic that doesn't just need to be in Rome2Rio web, in our web application, but it needs to be in our trip building application, and it's legitimate logic, you might want to turn it into a NuGet package. There's a lot of downsides to this. It means now you've got to worry about backwards compatibility, you've got to be worried about semantic versioning and publishing new versions and trying to make sure people are kept up to date. But it can work. It's really great for utility code. It's fine if there's, you're not worried that there's going to be different apps in production using different versions of that code. That's how we kind of look at it. If it is going to be a problem, chuck it into the API and slap an API endpoint layer over the top of it. This can be quite handy. And this question really comes down to, do you want that route finding logic? Does it actually belong in the business domain of trip building, or does it belong in somewhere else? Should it be there or not? And if it's going to be reused by other applications. The other option that sometimes doesn't occur to people is just to ask the question, well, actually, does that route finding logic actually belong in trip building at all? Maybe it's business-wise, it's not the right domain, and it actually just needs to be moved back into Rome2Rio web, and the trip building logic needs to be changed to not do route finding anymore. So that's about your main options and a couple of different solutions. Then there's the joys of when you might see this problem. You've got routefinder.cs, you start digging through the code. How many people have seen this? Routefinder2.cs, that's a copy, and there's about 5 lines that are different. I know I said dry isn't the worst thing in the world, but if it's in the same project, you know, not cool. If that happens, you might want to then consider trying to merge it together, slapping an enum over the top and saying, well, in this case, we want to use this one. In this case, we want to use this one. Is this all cool? Going too fast? All good? Making sense? Cool. So let's actually look down at the code level. So that was all looking at classes, but let's look at some code and how we're going to split that up. So let's say this is our code that builds a trip, vastly simplified, but it's doing 3 things. It's calculating routes, it is working out the price, and then working out the description. But for our trip building, let's say in this example, we don't want to actually do pricing in our trip building. We want to keep that in the monolith. So that logic doesn't really belong there. And I've had a close look at the calculate description function, and the calculate description doesn't depend on the pricing. So in this case, we can go, okay, cool. Let's move all the route building and the description building to happen first, and let's do the price building at the end. So what if we did that? It would look something like that. Build all the routes without pricing, and then do the pricing, do a loop. And then, of course, this does beg a problem. I won't get into that one yet. And then we've got that function then becomes our API code. So we had the build routes without pricing. That's the stuff that is actually the route building. Here's the function, we saw that before 3 slides ago. Calculate routes, do the descriptions, and return the trip. That's now our API code. We can now move that to a separate class. We can move that out to our .NET Standard project. There we go, we can move it out to a new class. Hopefully it's static and it's not referencing other things as well, then we've got to work out what to do with them if they are. But we've got another problem. That's just the actual logic, but we're returning a route. So we have a problem with our route has pricing, flights, trains, and descriptions. And for our trip building, we don't want to have to do anything to do with pricing. So we don't want to have this price object in the route class, but we need to move that route class in the .NET Standard project. So this is a technique that we use really extensively and really heavily, which is to move the route into the .NET Standard project, call it route without pricing, and subclass it, and in the monolith, inherit from it and add the properties that the monolith might need. And we use this really extensively, and it was actually a really nice pattern. It worked really well. We tried lots of different ways to kind of work our way around this problem to help move stuff into a separate project that's decoupled. This was a really good approach. And then what's great then is that because we have our nice classes with the pricing, without pricing, they become our DTOs. So we can reuse these existing classes that are here. I wouldn't recommend it because we had lots of other code in the monolith and trip building that depended on lots of other properties. So build some nice DTOs and then map from your DTOs to your business objects. And we've pretty much got almost all of our code here to call the API. We've got our function that's in .NET Standard. It's returning DTOs. It's got a nicely, the domain is right. And we can even change our code to start using these DTOs in the monolith while we're doing the trip building in the monolith. And we'll kind of simulate what will happen when we actually call the API and use the DTOs. We can all do it sort of in the monolith, deploy that daily, find out pros and cons, find bugs, fix them all up as we go. So yeah, interfaces are super helpful for us. Definitely recommend them. Subclassing. Interfaces as well. If you've got a big class and it's got heaps of functions, but some of them don't belong in your new domain, you can hide them behind using interfaces. Really, really handy. We use heaps of access modifiers, setting things as private and protected so that we knew that they were no longer accessed by the monolith. And you can do the same thing via extension methods, which we briefly investigated. Wouldn't recommend it. Not really their kind of intended use. I think their intended use is normally for when you don't really have access to the code. And it just wasn't a good fit, so I wouldn't recommend them. All right, so HTTP. So we've got to the point where we've got all of our separate code in .NET Standard. We've built our, there's our code. And we started calling our API. There's a problem here with this code. If fetch, let's say we've also created another API, which is fetch pricing. And that's actually now fetching it from the API. Probably should be await, by the way. Oh, by the way, if you're having an await function, please postfix the name of the function with async. Please do that. Some people just have the name of the function and then you can't tell that it's an async function. It should end with the word async. Yes, please do that. Thank you very much. End of rant. So if you're fetching a price from an API and you've retrofitted this code to call the API, whereas beforehand it was all just doing it in a separate function, you've now, for every route, you're calling your API. Architecturally, not cool. I mean, performance-wise, not cool. Instead of doing that, you want to just call it once and calculate it for multiple routes. But we found that trying to sort of just pull out existing code, chuck it, just wrap an API layer over the top, and previously the code would never expect that function call to not work, because now it's being called over HTTP. It might time out, it might fail, it might be so many more problems. Whereas there was no case of what happens when fetching pricing doesn't work. So trying to retrofit that to your code can be really difficult. So in that case, you'd want to get rid of that loop altogether, send over all of the routes, calculate all the prices, send it back. Next problem that we came across heavily, bandwidth problems. So let's say this is our DTO. We've got an array of all routes, and then we've added a couple of sort of little helper properties. So we've got .first route, which is the first item in the list, .last route, and then we've got a little expensive routes functionality, which is that lazily? Might be lazy. And when you hit that, it's going to return all of that. So that's great when you're all running it within your monolith and your application. And this is all happening in memory, and it's all using pointers. So adding new items here, you're not consuming any more memory, apart from the pointer. But if you're going to be sending this object now over the wire, suddenly you're serializing your collection, you're serializing first route, last route, and expensive routes. This was a big problem for us. We had to really go through all of our existing models that we converted to DTOs, calculated properties, make sure that they work out if they belong, which place they belong, or if at all, if you could just get rid of them. And maybe they don't, that logic actually shouldn't really be in your DTO class at all. Move it out somewhere else. So we had to go through the process sometimes of normalizing data. As I said before, if you're now suddenly returning all of this stuff, you might be returning lots of duplicate data. Because adding a pointer is cheap. So your location object might have a pointer to a geoposition that has a name, and then you have other things that also point towards other geopositions. I just made that class up. And so your JSON might be a lot bigger than it actually needs to be. So you want to start introducing IDs for those things and normalizing those things. We did this for a few of our APIs. In other cases, JSON wasn't a good fit for our APIs. We were returning way too much data. So we investigated, we ended up using, was it protobuf? I think it was, yep, protobuf. There's lots of other binary serializations, but that worked for us. So we're doing it from, well, the service already supported protobuf, so that made sense. So yeah, now that you've converted your code out to be in a separate service and you're calling it via HTTP, previously, if it was just a function call, it'd work most of the time. But now you're doing it over HTTP, and it's easy to kind of think to yourself, it's all running in the same cloud, it's all running in the same service, or the service is right next to it in the same location. 99% of the time, my calls are going to work, right? Yeah, they might. It's surprising how often you just get failures for seemingly no reason, or weird response codes. Timeouts were a big issue for us. And you really need to test locally your timeout logic, specifically in .NET. The way it can handle timeouts is, depending on the HTTP client that you're using, it's different, and it does it in different ways, in so many different ways. It might be the connection timing out, it might be the call that's timing out, and you need to test it all, make sure it's all handled well. The cancellation tokens, I think. What was that guy's name? Did anyone go to that talk, the async await talk that was on just before me? Yes? No? No. That was a great talk. Go back and watch that if you're doing async and await. You want to add in your retry logic if the call fails. Sometimes just a call will just fail. You get back a 500 or a 503. You might just better wait 1 second and call it again, and it'll just work. That actually became invaluable. We had to go through all of our source code and stick in retry logic for all of our HTTP calls. Circuit breakers. People do circuit breakers. Yes, maybe. So if you're calling your service a lot, you're making 100 calls a second. If it dies and you keep hitting it, all those requests are going to batch up. And if you try to bring it back up without spinning them all up in time, and you keep sending it requests, it might not be able to start up and recover in time. So if your application that's calling your service detects that the whole thing is just failing constantly, we set up a bunch of different thresholds depending on the service, you want to stop calling it so you can give it time to scale up and start back up again. That was actually really invaluable. We had to go through all of that and stick in circuit breakers everywhere. Caching, I mean, it solves a lot of problems, but it causes 100 other problems. But if you're calling an API, and a lot of the time you're calling it with the same inputs, if it's deterministic, you can add a 30-second delay, 30-second cache. Can really increase your performance. But there's lots of pros and cons to caching. And then async. Has anyone had to, so when you're making a HTTP call now, it should be an async call, right? So previously it probably wasn't. So if your function that's being called all the way down here is now an async call, you're gonna have to go all the way up your chain, you're gonna have to go all up your tree, make every single darn thing async await. Who has done that? Yes, lots of hands up. We can all meet up together and have a cry and a hug because it is painful, horrible, difficult work, but it needs to be done. We found that running in the cloud, we prefer to have lots of smaller services. So instead of having like 10 servers that have 8 CPUs, prefer to have 20 services with 4 CPUs. And you're kind of living life on the edge a little bit. Before we were massively over provisioned, but now you really need to make sure you're keeping close look of your threads. We had lots and lots of thread pooling, thread starvation issues, and we had to go through all of our code and make sure async is being used, done all the way up the chain. So anyone had to fix async over sync issues, doing it in the constructor, and horrific. But you have to do it. There's just no two ways about it. There's lots of people that post on how to do async over sync. Just don't do it. There's a guy, John Cleary, is that his name? Is the guru on async await. He's the guru. If you see anything posted by him, sorry, what's his name? Yeah. Stephen Cleary. He's the guy. He wrote the O'Reilly book, I think. If you see anything posted by him on how to use async and await, listen to him. He's the guy. Whereas there's lots of people who sort of say, you can just do this, it'll be fine. But nah, listen to Stephen Cleary. He's awesome. So a bunch of .NET specific stuff. I mean, some of that other stuff was, but will probably apply even if you're not doing .NET. We found that using the new HTTP client was pretty much mandatory. Previously, we were using, what's the old one called? Web request, and I think there's an older HTTP client. There's a couple of different ones, the .NET frameworky ones. But using the new HTTP client, we just had to move to it. It caters for lots of things that just aren't that much of a problem if you're calling another service that's just not running in the cloud. It does a lot of DNS things and security issues, and we had to go through all of our code and convert it all to use the new HTTP client, which in .NET Framework is a bit of a nightmare, because to create a new HTTP client, they want you to use dependency injection, and .NET Framework and dependency injection was never really designed. So we really had to go through and make all that work. Definitely worth doing. I can't actually remember how we did it. What did we do? You create what's that thing called? The service client? What's that thing called? Service collection. You create a new instance of your service collection at startup, and then you can provision new ones. I should say I've got a couple of Rome2Rio guys here that are legends that did a lot of this work, so I'm just looking there whenever I get stuck, which is nice. Thanks, guys. Reference comparisons. So if you had a function that's returning some objects, you might be able to check if those objects are duplicates. It'll work fine. If you're now calling an API and getting back those objects, references aren't going to work. But you're not going to be able to catch that problem at compile time. Everything will compile and run, but the reference just won't match. So this bit us quite a few times. So you need to go through your code, look for equals equals, and if there's two objects, just have a closer look at it. On a similar line, get hash code works differently in .NET Core as it does in .NET Framework. It doesn't just give different results. It works differently. It'll give different results even while on separate runs of the application. That bit us as well. And then because we're running on Linux, time zones. Just watch your time zones. Lots of issues with time zones. I think they're all actually fixed in .NET 6. But yeah, you still got to watch them because time zone names are different as they are in Linux as they are on Windows. .NET really takes care of a lot of that now, but if you had custom code, which of course we did, to look at time zone names, it ain't going to work. All right, how am I doing for time? I'm doing good, cool. Migration. So we moved to Kubernetes. Believe it or not, we moved to GCP. Does anyone use GCP? Apart from Rome2Rio people? A couple of people, cool. Works fine, yeah, no complaints. We ended up using for our monolith when it was just very, very small and it just had our legacy .NET framework stuff in it. We ran that we are running that in Kubernetes as Windows containers. That was pretty painful in GCP, but I mean, Windows containers are just painful, full stop. You can't really blame Google for that. So as part of moving to Kubernetes, we had to implement health check and readiness checks. Really important to get them right. .NET Core has a library to do readiness checks. We didn't know this, so of course we wrote our own. And then because you think, how hard can it be? You just return okay if it gets hit, right? But it does there's some weird things around receiving signals that we ended up implementing ourselves. And then we found out .NET Core has a readiness library that does that for you as well. So check that out. I can't remember what it's called, but just Google it, you'll find it. One of the other big things we had to do was to change our service to load in the reference data after the application has started up. So this is a Kubernetes thing, but we found that if you start up your app and it takes 2 or 3 minutes to start up, Kubernetes would just kill it. It would just refuse to wait that long for your health check to say it's okay. So we had to change all of our apps to start up, not load in any reference data or not do lots of stuff at startup, but then change the readiness probe to return I'm not ready, load all the startup data, and then once all the startup data is loaded, turn on the readiness probe. That worked really, really well. That was a really great pattern. But of course, it means changing your app quite a lot if you're already doing that at startup. Kubernetes seems to be designed around environment variables for handling environment-specific stuff. .NET Framework was never really designed to do that, so we had to kind of retrofit all of that in there as well. We wanted to run in read-only containers. We had lots of code that was accessing the disk, and in Kubernetes land, your Docker container might just be killed at any point in time, so writing to disk is not cool. So we did our best to get rid of it all. Would recommend that. I kind of mentioned this before, so we ran one new smaller service in the cloud. We started with a really small one and got that live, learnt a lot from that. When it was I guess for all these previous ones, I've been talking about internal services that our monolith is going to call. They're not actually public facing, but if it was a public facing API, we mirrored traffic to that API and just sent it production traffic and ignored the response. But production traffic is a weird and wonderful world. You never know what you're going to get. There's no substitution for it. So that was really handy in helping us find stability problems, scaling problems, errors, stuff like that. A real nightmare to do, actually. We ended up using something called Envoy, I think, is what we used for doing that, and it worked really well. I should say that we have 2 SREs that did a heap of this work, and they were awesome, and they're both absolute legends, and they're not here today, which is a real shame because they deserve so much of the glory. But yes, pay your SREs. SREs are worth just every dollar you can throw at them. They're great. So yeah, we just sent mirrored traffic, 1% of traffic to the monolith, compared the results, make sure it was giving back the same results. Once we were happy with it, slowly ramp up the traffic. As we receive a lot of traffic, we wanted to do lots and lots of performance testing for stability and for performance. So making sure that we're not making things worse. What we figured is that we're running pretty much the same code as what was in .NET Framework and in the monolith, but we're running it in .NET Core, and we found we got like a 10-20% increase purely because it's just running on .NET Core or .NET 9 or 8 or whatever it was. And so that was awesome. So that we were hoping that would sort of offset the overhead of calling the API and all of the HTTP and the bandwidth and all of that, and it did. Rinse and repeat. A couple of other handy hints that I hope are handy. .NET Core needs definitely at least 2 virtual CPUs to be happy for the garbage collection. Initially, we were running a 1 vCPU, or maybe even half a virtual CPU, which is dumb. It's just never going to work. So I think we're running on 4 for most things now, and it's much nicer. Yeah, don't try to be cheap, or don't try to keep them too small. This was a very, very hard-earned lesson. Thread starvation looks really weird. So we had lots of issues with thread starvation when we hadn't fixed our async and await code, and the app was, well, threads were being starved, your threads just start piling up. But within our code, it looked like our HTTP calls going out were timing out. But it was because our code was starved of threads to resume to receive the response back. And so, yeah, look at your number of threads. You need your monitoring so you can look at your number of threads in your service and work out and as soon as you see it starting to go out like that, that's your problem. I did another talk on performance profiling and optimization a month or 2 ago at DDD. We talk about a lot of these issues, so go look that one up. It's on YouTube. It's pretty good. Garbage collection problems. We had lots of garbage collection problems. We did do a big pass through of our code to try to fix obvious performance issues. We still found that for metrics like P99, there was still quite a lot of times where the some requests were just really, really slow, and it was because the garbage collection was running. We found that for our more heavy-duty algorithmic code, CPU-intensive code, we turn off the readiness probe when we're about to do a garbage collection. And garbage collection was taken like 3-5 seconds. And that worked really well. Once you've got enough instances running, you can do that and get away with it. Not a great solution. I know they've made a lot of changes with .NET 9. Has anyone moved from .NET 8 to .NET 9 and seen a difference in their garbage collection patterns? If so, I'd love to talk to you and to try to get to the bottom of that and see if we can, hopefully that'll solve some of our issues. I've talked about thread starvation problems. And we also found quite a few sort of obscure code paths. If somebody was planning a trip from one location to another location where there was a lot of transit or there was just a lot of something that we didn't really expect, they would slow down. And yeah, running in the cloud and running in smaller containers, you're kind of living life on the edge. You want to get your CPU utilization up quite high. But if you find one that's really slow that's now chewing up all the CPU, you get into trouble. So we spent a lot of time chasing down some requests that were slow and fixing those up. Whew. All right, so ripping off the Band-Aid. So once we'd moved the majority of our services into GCP, at some stage we needed to go, we've done as much as we can. What's left in our monolith is .NET Framework code that doesn't receive a lot of traffic, but we still need it there. It's not worth spending months porting it or rewriting it. So we converted that to, so we use Windows containers for that. Anyone use Windows containers? Anyone use Windows containers? Okay, you're all very lucky people. I mean, it's completely fair on Microsoft. I mean, Windows was never designed to do it. It's a miracle that it works at all. And it did actually work really, really well. The application ran just exactly the same in a Windows container as it did on our bare metal servers. So it was cool. It was a really good solution. So we did actually do it. It was a little bit terrifying. I think we made the switch at the start of this year. I submitted this talk in November, so I wasn't actually sure if we would actually get it done by then, and if I was just going to be, spouting a full load of nonsense. But we have actually done it. Here's an example of the CPU. So the blue is the .NET Framework monolith, and then the purple, sorry if you're colorblind or something, is the .NET Core version of it. And you can see so this is running 50%. 50% of traffic is going to still Rome2Rio Web, and 50% is going to the .NET Core version. But you can see the CPU usage for the .NET Core version is what? It's like a fifth or something of the .NET Framework one. Really, really cool. So there's just been so many performance optimizations in .NET Core, and obviously Framework is legacy now, that it just really, really made it was worth doing it. We did get the performance down, which is great. Average response time, as seen by Google, has dropped, which was awesome. It was up pretty high while we're in the middle of things, especially calling lots of APIs from our legacy data center to GCP. That was quite slow, of course, but we have got it down, so it is possible. And we got auto scaling working, which is very nice. It's 2 different services. Our peak time is America's middle of the day or something like that. So our peak time is like our 1 a.m, of course. So you can see it sort of scaling up at night time and then scaling down. How am I doing for time? How much time have I got left? Can someone yell out? I've got a timer here, but I don't know when I started. 10 minutes, roughly? 20? 10, okay, cool. Outcomes. While doing this, we moved all of our services to continuous delivery, and far out, it's good. At my last place that I worked, we still had things that were done manually, and it took a month to do a release, and it was a total nightmare. When I came to Rome2Rio, releases were done daily, and I'm like, yeah, this is awesome, daily releases. And then now that we've moved all our services to continuous delivery, as soon as you merge, it deploys to production. Now that I've gone back to, when we went back to the monolith daily releases, I'm like, oh man, daily releases are horrible. So yeah, we moved all these services to continuous delivery, and it's really good. It is worth doing. Website is faster. Yeah, smaller services are much easier to work on. So with the trip building logic, we are still in the process of completely decoupling it, but it is completely separate, most of it, 99% of it, and we have handed it off to another team who have been able to really work on that, make lots of changes, and not worry about breaking the rest of the code and doing continuous delivery. Yeah, it's really cool. Of course, it's .NET Core, so you can develop on a Mac. I mean, how many people use Macs? How many people develop on a Mac? How many people develop on Windows? Windows, everyone? Yes, I saw one Mac guy. Yeah, so you can develop on a Mac if you want to. And I'm not going to lie to you, hosting in the cloud, much more expensive. Much, much more expensive. We're hoping it'll be cheaper, but it was not cheaper. But we have saved so much time in terms of troubleshooting and maintaining and patching our bare metal production servers. We've saved heaps of time. So I'm sure the costs, I mean, I haven't talked to the finance guy or anything, but I'm sure the costs outweigh the costs of hosting it in the cloud. If you look at developer productivity and just how much time we spent troubleshooting, if a server goes down or creating another bare metal server or whatever. Observability in .NET Core is awesome. We use Datadog. I love it. I think it's absolute best. If you can move to Datadog or something equivalent, go for it. Yeah, really, really cool. And then, of course, the big downside at breaking up your monolith into multiple services, you've added a lot more complexity. So it's really nice. It does mean that one team can then work on that one service and deploy that and change that as often as they like. But distributed architecture, it does add a lot of complexity. Only once or twice I have thought to myself, man, it'd be nice if all this code was still in the one place and I could just make the one change and deploy everything, Yes, definitely a thing. So learnings, if I look back at the last, this has probably taken, how long has it taken? 2 years, 3 years? 3 years, I reckon. It was really, really difficult. Anyone tells you this is going to be really easy is lying, or just hasn't done it before, or doesn't know. It was really, really difficult. The success of any really, really big project, I think the number one factor is, do you have management support? So we were incredibly lucky that our engineering manager was fully 100% behind us and gave us all the support we needed, and it was great. But if you don't have that, boy, you're going to struggle. Good luck to you. A good SRE is worth any amount of money. SREs are the best. Hire SREs. I thought I was an SRE until I actually met one and talked to a few, and I am not an SRE. So hire some good SREs, and they are great. Sometimes listening to them talk, I'm like, yep, I have no idea what you're talking about. Yeah, and running on the cloud is, a bit like living life on the edge. I kind of mentioned that one before. Another one that I've kind of noticed in the past 6 months or a year is, now that we've sort of broken up our monolith into separate services, getting people, developers, to think in terms of not breaking the API contract and maintaining backwards compatibility. It's a big change. So in the past, you'd sort of have we had a big monolith and big monorepo, hit compile, you hit run, and it works. Now you've got to think about, well, do we want to break compatibility? Do we need a new endpoint? How do we, what about our data? I haven't even talked about data. That's a whole nother issue. But getting devs to think in terms of moving from a monolith to services is a big part of the work. And so we spent a lot of time educating people on how things we want them to work now. Another thing that's kind of overlooked is it's easy to kind of go, great, we've converted everything to .NET Core, it runs faster, there's lots of technical benefits of .NET Core, it runs on Linux, great. But there's heaps of non-tech benefits for a business in using a modern tech stack. It's great for like employee morale. I mean, who wants to work on .NET Framework anymore? And it makes hiring a lot easier. People want to work on newer tech. And yeah, it's easy to kind of overlook these things when some managers might kind of go, you nerds just want to do that because all you care about is latest technology. But it can actually really help the business as well. That's a lot. There is a blog post, not a blog post, a big article up on the site, but if you just Google Rome2Rio splitting up the monolith, it's there. I go into a bit more detail on some of these topics. So that's it. Thanks for having me. Just one more thing I did think of. We've got other people from Rome2Rio here. Come on, Tom, stand up. Aiden, stand up. These guys, stand up, turn around. These guys were extremely instrumental in doing a lot of the cloud stuff. So if you don't want to talk to me or if I'm busy, talk to these guys. They know everything that I know. They did heaps of the work as well and were extremely helpful as well. So thanks, guys.